Welcome back to my Commodore 64 Memories videos. This is where I look at old Commodore 64 software and some of the technical details behind them. Today we have Way Out, published in 1983 by Sirius Software, created by Paul Allen Edelstein. This game was suggested by one of my viewers, so let's get into it. We have this little colour bar scrolly intro giving the name of the game, and then a choice between keyboard, paddle and joystick. I'm going to choose joystick. Already I can see some title screen text in the debug view, but I can also see some disk command text as well in that memory debug dump. We have the level selection screen, so I just selected the first level. I can see there's a bit of extra loading going on. Now here we go. Now, for 1983, this is actually a really unusual game in that we've got what looks like a 3D raycaster rendering what looks like a free-ish 3D maze. We've got a text screen, I think, rendering this. Yep, looks like a text screen. Actually, the screen is still in the default pages at 400 in hex. Okay, we've got a character set there for what looks like the lower part, which is the currently uncovered part of the maze that we can actually see as we rotate the camera around. Okay, so we've got one character set there. Okay, we've got two character sets there. Look at 2000 and 2800. And so that means that it's one screen with a regular pattern text layout in that screen. And then we've got two character sets for the middle portion of the screen. And that means that we've got a double buffered character set, one for each view, of course. While it's calculating one view, it renders the other, or it shows the other. And then we've got another character set at 3000 in hex, which is the Way Out logo and the north, south, east, west compass points at the top. And then we've got another character set at 3800 in hex, which is a slightly fancy looking font, isn't it? And the slightly fancy looking font is laid out in the same kind of like order, I think, as the regular character ROM font. So we've got 4 character sets in the first video bank plus one screen, which doesn't seem to be changing during the game. We have that reversed text there in the text screen, giving Paul's name and the copyright message for Sirius. But yes, I think we're going to have a look at how this game renders this view as well. I think we'll have a little dive into that because, you know, it's really unusual, right? But if you note here, look, I'm pausing the game and advancing one frame at a time. And you can see in the Commodore 64 view that the sky or the ceiling or whatever it is actually using bands of quickly alternating kind of like complementary colors, which if I allow the emulator to execute at full speed, and I don't know how well this is going to come across in the video capture, but when it's rendering at full speed at 50 frames a second, those complementary colors, because they're flickering quite rapidly, they produce like a halftone, a color in between, especially on a emulated PAL display, CRT display, or on a real CRT, as this would have been shown in 1983. It would have shown a wider range of colours. So alternating and flashing colours like that helps the CRT to display a wider variation of colours. But yeah, this regularly laid out character set here in the screen. Look, this is kind of like the secret to this game, if you like. The middle maze portion of the screen is rendered with that regular grid of characters. And we can see the reversed characters in the bottom as well. So the top half, the top 128 characters of that character set is going to be used for the game display. And the bottom 128 characters is probably going to have a flipped version of what is rendered in the top, minus the horizontal bands for the sky and stuff like that. There's quite a lot of text in these few memory pages here, nestled within the middle of the code. Maze inilo, maze in. Okay, yeah. This is a disk command, or it looks like a couple of disk commands, maybe, or at least one disk command. Like a 2,0,0,02,00. Apple Editor Assembler, current assembler ID stamp. Is that ID stamp? Is colon. That's intriguing. Current assembler ID stamp is. Okay. But the Apple Editor Assembler is an interesting thing to see in the middle there. What's in the next page? Oh, that's even weirder. Look. Insert write protected Pascal disk. Pascal is being one of the computer languages from the dim distant past. Insert source disks there. I don't know. Would this game have been written in Pascal, or was that just something floating around in memory when the game was being mastered? I wonder if Paul knows the answer to that. So this was coded in 1983 when I was 10 years old. So it probably contains a bit of maths which I wouldn't really understand when I was 10 years old. Let's see if there's any files on the disk that can get recovered. Yes, there are some recoverable files on the disk. So my updated C1541 tool has some extra options in there for scanning the disk and recovering what looks like file chains. There wasn't anything hidden in the directory and block allocation map on track and sector 18.0. But yeah, these file chains, some of them look like they might contain data. Look, source disk, slot, target disk, slot colon, drive colon. Okay. Insert write protected Pascal disk. Okay. So when trying to recover file chains from a disk, it often doesn't lead too much. Usually a disk is wiped clean and then assembled from scratch. But you know, sometimes some of the older disks do contain some useful data. I think I remember one game, right, I was looking at in these videos, and one game contained an unprotected version of the game that had been deleted and then replaced with the protected version of the game, which was quite funny. Yeah, none of these files seem to contain much useful information. I think I saw some GCR decoding errors as well. So this disk does seem to have some badly formatted or protected formatted tracks and sectors perhaps in this disk. Not going to look at that in too much detail, to be honest. I don't think. From 1983, I'm not. The protection is probably not going to be that interesting. I'm more interested actually in the rendering of this game, because the rendering of this game is quite advanced but quite unusual, right, for 1983. Maybe this is the start of a file that's been recovered here. That looks like it might be a sys16384. It looks like it loads at 801, but whether or not the later track and sector information is complete is another matter. I don't think it looks complete. It looks like that's sys16384. It looks like it wasn't jumping into what looks like machine code or anything, so perhaps not. Perhaps it's just a fragment of data that is badly recoverable towards the end. Okay, anyway, so I don't think there's anything on those recovered files from the disk. So let's start looking at the game and see if we can understand a little bit more about how the game works. So as I'm wandering around, look, this zoomed in portion of the memory view here is constantly reading these green coloured bytes from memory, kind of like floating around in the middle of the Commodore 64's memory view there. Look, if I zoom out, and then you can see those green bytes there, kind of like in the middle. So that's probably around about 8,000 in hex. kind of like in the middle of the Commodore 64 memory. But look, if I rotate the view left and right, the bytes that were being read change. It shifted left and right in the view as I was rotating left and right. Just trying to remember what it was that I need to change. Oh yeah, okay. I can never remember the keyboard shortcuts, even though I use this tool really very often. Anyway, so let's zoom in and then let's see what we get when we change values, shall we? Because look, if I rotate left and right, the green red bytes in that memory also kind of like rotate left and right. Okay, oh, yeah, that's right. In this game, I think there's kind of like wind or something that tries to push you out of the way of getting to the exit. So this first level, right, you can see where the exit is. You need to go straight forward, and you try going straight forward, and then it blows you out of the way, and then it blows you through to a different portion of the maze. So you need to find a way around the maze. Anyway, so let's start editing these values, right? Because we can do that in these tools now. And we'll just edit these values and we'll see what changes on the screen, right? Did something change there? I think it did, right? Let's keep a careful eye on the screen. Okay, let's keep on going. No, okay. Did something change there? Let's keep on going. Okay, so we're experimenting. We're seeing what happens when lots of values are being changed to 0. Oh, well, the game hasn't crashed. I think something is changing, right? If I change... Okay, let's change these now. Aha, yeah, definitely. One of the walls there on the left-hand portion disappeared. Aha, that's made the other walls that were facing the camera disappear. Okay, that's made more stuff disappear. Ah, look, that's removed that wall which was closest to the camera as well. Interesting. Let's change. That's interesting. If I change it to FF, then the walls come back. And now if I change it to 0, the walls go away again. That is interesting. Let's add 1 bit at a time. Let's see what happens when I change 1 bit at a time. So I'm counting up in binary now. 1, 2, 4, 8, and then 16, which is 1, 0, and then 2, 0 in hex. That's the next wall along. Let's change it to 4, 0. Let's go to 8 first, and then let's go back to 2. Okay, let's change that. Oh, I messed up the memory view. Whoops, I'll just have to recover that. Sometimes the memory view gets messed up in this. I pressed the wrong key and it obviously split the portion of where I'm editing. So there we go. Okay, these higher order bits, if I edit these ones, okay. So that if I make that, let's see if I make, okay, so there's something weird in this layout here, right? Well, that removed the whole bunch of walls. Let's remove that one too. That removed the whole bunch of walls further in the distance. That added a whole bunch of walls in the far distance, look, over there on the right hand side, and that gets rid of the walls in the far right hand side. And that brings a whole bunch of walls. I think that byte there is a whole bunch of walls that are facing kind of like the camera, mostly facing the camera anyway. That's the closer walls. Maybe it's a bit pattern, because adding FF seems to add what, 1, 2, 3, 4 at least walls that are visible there. If I add FF here, then the walls are far into the distance. Okay. I have a feeling that byte there, I have a feeling that that's walls further away. Yeah, look. Yeah, if I change that 1, 2, 4 and then 0, yeah, make it 0 again. Okay, so 1, 2 and 4 were bringing values closer to us, or closer to the camera. Let's make that 4. Okay, let's put it 8. Okay, let's make that 1, 0. Right, that's the wall that's closest to the camera now, and that's the wall that's next further away, and then that's the wall further away again, and that's the wall further away again. Okay, So it seems to be the byte on the right hand side is the one at least closest to the camera in the current orientation and position where the camera is. And then as I increased the bits or went into the next byte to the left, it seemed to push walls further and further out to the left, further away from the camera. Okay, so something in here is definitely changing the walls that are visible. If you notice on this view, we don't have any walls which go left to right. It's all the walls which go further into the distance. I've rotated the camera around as well, don't forget. Just rotating the camera around, and I can see actually that most of the level is empty. It's certainly near the camera now. The map view hasn't reflected the great big empty room that I seem to have created by editing all of those values to 0, but yeah, certainly the 3D view shows that we have a great big empty room. So that's the exit there, which you have to try and get to, right? As I'm rotating the camera around left and right. Okay, that's the view that we had before. Let's fill in these values. Look, those values there, the ones at 8A00 to 8AFF, right? They seem to be a bit field structure for the walls, but those were across one axis, and then the values at 8B to 8BFF seem to be a bit filled for walls for the other axis, 90 degrees off from the other one, right? So we have two axes. Okay, so that seems to be the level definition, right? 8B is a memory location, and that seems to be the walls around where the player position is on the first level, and the player position spawns near the exit as well, of course. Let's just move over there, and then let's move, because we're avoiding the wind area of the level, you see. There we go. I've just completed the level by cheating and basically removing the walls so I could go around the other side of the level, and I managed to complete the level intro in 5 units, which is inconceivably quick for a short distance. And then I can, that's where that slightly fancy character set is used. Look, it's used in the high score entry, of course. Just enter my initials, MLP. Then there's my new low score. All of the rest of the high score entries are empty, of course. The idea of this game is to get the lowest score, which is the lowest, shortest distance travelled, I guess, instead of a high score. Another thing that makes this game a bit unusual, right? So let's restart the game, looking directly at the exit from the default start position, and then let's edit some of these values in the 8A to 8B00 range. Let's change some of these to 0 so that we can understand the level data in a little bit more detail, just to really confirm what we think we understand. So I'm just looking for the precise values which allow me to edit the walls directly in front of the camera. So those are the walls that are facing the camera just to the right. I think those were the left to right walls. But these are the walls which are facing the camera, so running effectively north to south. If we look at the compass, and I think that's behind the exit, or at least one to the right of the exit. Just checking to see what other values. Okay, so what other values are being edited? Okay, that was definitely the walls facing the camera, one to the left of the exit. So one step to the west. Okay. And that's the walls north-south oriented that are facing the camera directly on the same coordinate where the player position where the player start position is. So this is important to know, but it seems that the stride, in other words, how many bytes make up a coordinate, it seems to be 4. So if we're assuming that the walls have 1 bit per wall and there are 4 bytes per, kind of like coordinate base, if you like, then that means 4 times 8 bytes, 2 times 16 is 32 bytes, 32 bits, right? A coordinate base of 32. So maybe it's 32 coordinate bases deep, perhaps, in terms of north to south orientation. And because it's a whole page horizontally, maybe it's 256 divided by 4, 128 divided by 2, 64. So maybe the map is 64 pixels or 64 units by 32 units. So maybe the map is wider than it is deeper away from the camera, or maybe it's 64 units west to east, in other words, and 32 units north to south. But that's what the level format seems to be in memory. This doesn't account for the enemy or whatever it is, the flashing blob that runs around the level after you, I think, and it doesn't account for the exit. That's going to be somewhere else in memory, but at least the level layout seems to be a bit per unit, indicating an on or off wall for the west to east walls in 8A00 to 8AFF, and the north to south walls in 8B00 to 8BFF. If I rotate the camera to the left and right, you'll be able to see those 2 character sets update as well. And the character set seems to update. So the kind of like the characters in the middle bottom portion of the screen don't seem to update that often because the walls don't get that close where the camera was. But now as I move the walls closer, then those characters get filled in. So yeah, there seems to be kind of like a fill portion of the code which kind of probably optimally fills in the graphic characters. But also if it's an empty space in the character set in terms of a view, then it doesn't seem to update those characters by filling them in with 0. Maybe it's not colorizing it, because I can see the color screen accesses. I can see the color screen on the right hand side of the memory view is actually not getting accessed, apparently. Really? Maybe there is. No, that's the IO space. Okay, well, that's intriguing. What's going on there then? Okay, well, need to dissect a little bit more, I think, the draw routine and how that works. Since we know that 8B7E is used for the walls facing us, let's put a watch breakpoint on that. And oh look, straight away we can see some code there, ending it with 8B00, Y. Y is 7E, so that's accessing the byte which represents the bit field for the walls which are facing the camera in this current rotation anyway. So this seems to be the start of the code, which is dealing with at least processing data from the map bit field grid array, if you like. The character set information, I'm just clearing the whole character set there with that fill memory command. Then let's see what happens when this code is executed. But yeah, it's definitely accessing the memory range 4B00. Oh, sorry, 4B00, right? No, 8B00. Accessing the memory range 8B00, which was the walls which are facing the camera, right? Let's get both text screens up on the screen, but we'll use the different character sets because we know that we're double buffering with our character sets. Let's change it around so the first character set and the second character set are at the top and bottom respectively. Makes it easier to think about, right? Let's fill the whole character set range, the double buffered character set range. So we'll fill both character sets. And then we'll see what this code does as it reads the array of bits for the walls facing the camera. It seems to be going left to right as well. Well, that did kind of like a full render, right? So that's so although it's accessing the wall map data, bit fields, in other words, it seems to be doing a lot more rendering. So it's not doing the render straight away as it's accessing that. It seemed to be doing a whole bunch of accesses for the whole bit field, for the whole map data, and then doing the render somewhere else because the breakpoint wasn't incrementally rendering stuff to the character set. The character set just rendered all in one great big jump. So I think we'll fill the character set again in memory. As I step over this, look at the Y coordinate is just increasing, and then, or rather the Y index register is increasing. Yeah, look at that, see? And then it goes and does a whole bunch of rendering elsewhere. Yeah, okay. So let's fill the character set data again. Let's delete all of the breakpoints, but do a watch store point now, watch breakpoint in other words, on writing to memory for anywhere within the character set. Okay, so this does load from the character set information, EORing with something, ANDing it with a mask, and then EORing it back again. Okay, so that might be an EOR masked fill of, oh, look, as I step over this routine, it's drawing one pixel at a time into the character set. That's interesting. So this seems to be stepping over left to right and tracing the top edge of walls which are facing the camera, or just generally the view, right? So this is tracing out the top edge. Okay. Well, that was relatively easy to find, almost straight away. So that's tracing it from left to right, and that's probably a factor of just having the camera rotation and orientation and position in the right way, right? But yeah, this is, and then we have a whole bunch of loading and storing from one area of the character set to another area in the character set. Okay, so that 2300 is relatively early on in the character set, and then 2700 or 2702 is relatively late in the character set. Okay, so that looks like it might be, let's just step over this a bit, but it looks like it's probably doing some kind of masked fill with the top of the row of pixels representing the top row of the visible walls, right? And then it's probably going to be filling down in columns. I'm guessing that would be the optimal way of doing it. So you fill with a mask for the first few rows as the top row of the pixel data moves up and down, and then you can fast fill an entire column of 8 bits, which in multicolor mode is 4 pixels because each pixel in multicolor mode is 2 bits wide. But there seems to be, maybe there's probably a mirror going on as well of the top row to the bottom row perhaps. But you know, if you're filling from top to bottom anyway, and you know the setup and if you know how the top line is drawn, you don't need to redo the same work for the bottom line as you're filling it. You can just mirror the fill. You can mirror from the top to the bottom, and then that's a lot quicker because you don't need to duplicate the work for calculating the bottom row. You just mirror what the top row is. That would be the way that I would do it anyway, especially considering that the character set, the text screen is displaying the mirrored displaying the second portion of the character set data in the bottom half. Right, that makes that way of representing a grid, and there we go. See, look, it's filled 4 separate columns by the looks of that relatively quickly, and that might be because the same routine there is being called 4 times JSR 6A B9 1 2 3 4. The same routine, you see, might be filling the character set with 4 different high byte values, but keeping the low byte. So you have to update the high byte values less often because you're reusing the low byte index or something like that. So a character set, because it's 256 characters, 100 in hex, and because you have 8 bytes per character, because each character cell is 8 rows, and each row is 1 byte, because it's 8 pixels or 4 pixels horizontally for multicolor. Then each whole character set is 800 bytes in hex, or 8 times 256 in decimal. 8 times 256 is 4 times 512, 2 times 1024, or 1 times 2048, 2K. In other words, 2048 bytes in decimal is 2K, 2 kilobytes. Because don't forget, a kilobyte is 1024 bytes, or 400 bytes in hex, depending on how you're counting. Anyway, so that's the 4 JSRs doing the 4 columns. And that's probably the high byte the low byte for the address utilization, but then updating the high byte. You only need to do that 4 times, you see, because you're updating the first half of the character set. Yep. Okay, so you're updating the first kilobyte for the top half of the character set and then updating the bottom half. So it seems to be doing a nice optimal column store, because that routine there seemed to be plotting into the columns actually quite quickly. As I was stepping over it, it seemed to be filling in the columns, right? Let's delve into this in a little bit more detail. So with a breakpoint here at 4 EDD, if I fill the character set with 0, there we go, look, each breakpoint when that hits, it's drawing one kind of like segment of the walls from left to right, currently anyway. And then this routine draws the individual pixels for each individual segment. These routines seem to be messing around with information on the stack as well, because if I do a step over on some of these JSRs, it's not doing a clean step over, it's actually drawing or rendering larger chunk or executing larger chunks of code than I expect. Maybe this table here at 9200 is probably a calculated table of the maximum, or rather the minimum Y value on the screen as it does its traversal through the bitfield map data. So at memory address 62CB, I found this whole sequence of JSRs which seem to do various calculations and then drawing the top edge and then filling the columns and basically rendering the bottom half of the character set information as well. So it seems to be doing a mirror from whatever is rendered in the top to the column fill to then filling in the bottom by mirroring what's there. So for this level, you can see in the top character set view, in the top screen view there, that we have a horizontal line and then a nice diagonal line for a right-hand wall going off into the distance. So if I edit the pixels in the graphics map, in the character set view here, this demonstrates very clearly that it's filling. So after this top wiggly line has been drawn for the top visible top of the wall, right, I'm going to edit some pixels in the character set view, and then this will update the view in a very strange way, right? So I'm basically tracing in kind of like my own wiggly top line. Now, this graphics map editor isn't set up in a way that allows me to edit pixels in a coherent view. But I can edit the character set, and then I can create these wiggly lines, right? So then if I step over this routine now, which should fill in the columns, we're going to get what looks like a badly filled in column view, but we'll see that the top half is mirrored in the bottom half. There we go. So there's a mirror line across the middle, and then the bottom is just mirrored from the top. So whatever data we put in by drawing into the character set affects the fill, and then affects the column fill, and then it affects what is drawn mirrored in the bottom part of the screen. So that shows that the bottom part of the game, after it's rendered the top view, doesn't look into what has been calculated previously in terms of the pixel positions at the top of the edges. It's just mirroring the data into the bottom. And I think we saw a similar thing as well in Encounter, I think Encounter had kind of like an optimized way of pulling in characters, whereas this, it has a regular grid of characters, and it just calculates the character set data into that regular grid. But anyway, that's how this game renders. We have the map data is basically two arrays of bit fields, one for the east-west and then one for the north-south walls. And then we have the top line of the screen being drawn in pixels, and then we have the optimized column fill, and then we have the mirroring of the data into the second half of the character set. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. Take care, have a great day, evening or night, wherever you are.